All right, welcome back. Today we're going to cover testing with frameworks. So we've covered kind of building a random bag, and so that's in a different lecture, short or mini lecture. So watch that. That goes over how to build the data structure. Today we're going to cover, or in this video, we're going to cover the testing of that data structure. So we can go through a little bit about testing first. And so we want to cover what we have covered before. We've done basic testing. So basic testing is when we write our own frameworks. And so that can be limited in scalability and limited in portability. So our own tests, our own Boolean functions, and so we have that all set up in a main, and then we call our individual tests, and then we somehow report all of that data. And so we have here an example main that uses simple test1, test2 predicate function calls, and then reports just a pass-fail rate. Right? And so that doesn't give us much information about which tests passed or failed, but that is a basic testing setup. And so if we go through and see what we would do for our random bag data structure, we would have to either output our test's failure, so we have IOStream included there if we're going to do output to CAir or cout. And then in our main, we also have output. But we call each of these tests we see here. We have test1 and test2 called in the ternary operator, and all they do is execute some basic setup. So this tests the constructor and the size function, and then test2 attempts to test add by adding a bunch of things, 100 things to be precise, to the random bag, and then goes about testing the size again. So we still can't test the quantity because, as we saw when we were doing the random bag creation, things go into the random bag data structure, but we can't easily check whether we have the next thing. We can't see the contents. So there's no way to kind of check to make sure that got inserted without just extracting everything. And extraction is a different function, pulling from the random bag. So here we're just testing the add to make sure that we're properly inserting different things, so 100 things, into the random bag. So when it comes to testing, more robust testing leads to using frameworks. Frameworks allow us to be more portable and scalable. Specifically, there are two frameworks we will work with, and you get to choose which you wish to work with. And these are two well-known frameworks, Catch and Google Test. So the Catch version that we'll have you use is version 1.x, right? Instead of the Catch 2 or Catch 3 is actually what it is now. But 1.x allows us to include a single header. And then Google Test has installation, and if you're running Linux, that's pretty easy. Both of these are stored on GitHub, and so we see Catch here, and then on GitHub's Catch area, and then Google Tests. And so both of them can be accessed with the code, the currently live code, and the currently generated code. And if you want to install, there's usually different pathways for installation. So the reason we use Catch 1.0 is because the versions after that, so the versions 2 and 3, they mimic more like Google Test, where you have to go and install everything. So version 1.x is where we want to start. So you see 1.x here in the single header version. So as I said, the Catch testing framework uses a single header. Well, the 1.x version uses a single header, and we'll often give you that with your projects, but you can also grab it from their GitHub, and it's just a single header version, and it allows you to include that header at the top of your file and then run your tests. So it's a simple setup because it's only a single include. However, because it's a single include, that means it's going to include a lot of stuff that you may not need. And then that means it's going to be more memory intensive, creating a larger executable file. It also takes longer to compile. So that all can be a limiting factor based on where you're working. Right? Some of those online systems don't agree with the catch framework because they limit the amount of time your process can run, and catch will take sometimes a little bit of time to compile, which means that your process for compilation might actually be killed by that virtual machine if you're using an online editor. And so that's the trade-off with the catch framework. So we see here the creation, so the make, which is linked in the description of the video, but also at the class resources. So this makefile has two options, ctest and gtest, just for catch framework and Google test framework development, right? And so all it does is run a compilation on the ctests.cpp, the catch framework tests instead of the Google tests, and then we run it, make run, and we see the output from the catch framework here down with all tests passed. And so that is what we would expect to see if we have properly and fully tested our program, as well as it's passing all the tests. So we'll see in the live environment some of the failing points, like it will force a test to fail, but that is an example here of all tests passed. And two example tests we have is the just basic setup we want to show you for the catch framework. So we take that key function here named test case, and then we have a string that is the descriptor of the test. And then we repeat that for every test case, and all of these would go in the same file in that ctests.cpp. And so it's a simple, we can create some simple descriptions of the tests, right? So example, empty test, we're going to check an empty bag creation. So that's the constructor test. The empty, obviously, there's nothing in it, so it's not going to require anything. However, the constructor check will require size, because we call size here, meaning that if size isn't implemented, we don't expect this test to be successful. So we have to implement both the constructor, the creation of the object, whatever the default constructor is here, as well as the size function for this one test to pass. And so that's what we'll need for those two tests. So every time you write a test, you can actually put a few things in the requires, because that kind of gives anyone that's reading your test a description of what the test is checking for overall, and then what actually needs to pass, or functions that need to be implemented in order to test this other functionality, right? And so you might have several things listed here, even though it's not testing the size function, right? We're not testing the size function here. We're testing the constructor. We say that we're testing the construction, which requires us to have size implemented. So the Google test framework is the second framework, and it's very straightforward to set up in Linux. Outside of Linux, it is hard to set up. Make, right? So the gtest here, again, we're just getting that Google test framework CPP. We also have several flags that are included with the compilation of the Google test framework. So notably, this one right here is going to tell us that we don't have a main function with our program. So Google test should generate a main function that simply calls all of our tests. So it's cumbersome to install unless you have Linux, or you are working in the Windows subsystem for Linux, WSL, on Windows. So otherwise, for Macs and for Windows, it's harder to install, and it can be cumbersome. So there are IDEs that already install it for you. The full-blown Visual Studio comes with Google Test usually installed. That doesn't mean it's set up correctly. That means it's installed. So it's usually easier to stick with Catch if you're having struggles implementing or trying to get Google Testing Framework to get set up. And there are tutorials for both the Mac and the Windows side. The easiest way for the Windows side, obviously, is to get the Windows subsystem for Linux, WSL, working, and then you can just install it as if you're on Linux. And so some of you may have done that with the early setup already on the WSL early in the semester, which means you may already have gone through and done the steps to install the Google Testing Framework as well. So those are the steps. Multiple files are required. So we'll see we include a header, but that header, and because we're installing essentially the Google Test Framework, we can have multiple files, but then the trade-off against Catch is that it's now more memory efficient because instead of having a single header that includes everything under the sun, we're just going to include the things that we need for our executable to run, the things that we're using within the Google Test Framework. So this is an example again, as we see the basic setup, we have test case 0, looks almost the same as what we saw with Catch, except now we have test, and then we have our class name, and then usually our function name or some sort of descriptor for this test case. So in here we have just one. This is test case 1 of the RandomBag class. This is no test, right? Or we could put 0 there. But so those get combined. We see here in the output, we have different names. So you'd want to be consistent, right? Usually when you're testing a function, you would say that function's name, but you might have multiple of those tests. So it could be add 1, add 2, add 3, and so on and so forth if you have multiple add function tests. We see here the execution. Google Test Framework has flags that you can send to the creation so that when it gets executed, you can output different things. So instead of just outputting all of this information with the timings for each test and whether it passed individual tests or information from individual tests, you could get a more condensed printout as well. But by default, this is what we see, each individual test running and then passing okay. If it didn't pass, we would get a failure here. And so then we would also get a printout of what. So what are we going to do with these frameworks? So we have the choice between Catch and Google, and so it's up to you to choose which framework you're going to work with. The reason frameworks are useful is because they make collaboration much easier with creation of tests. And so that standardization allows you to take other people's tests and use them, or once you're in industry, you're building a giant test suite of all these tests versus only having your tests to work with. And then that scalability is also easier because you're not trying to invent the framework, right? The framework is there for you. You just have to abide by its use cases. But you have to remember, we taught you basic testing for a reason. That is the fallback, but also that's sometimes all you need. Sometimes you don't need a giant test suite of tests to test a couple basic things, right? You're just trying to assess something. And so you don't always need to go about implementing full-blown framework with your programs, projects, side projects, things like that. Okay, we're going to jump into a live coding example demonstrating each of the test suites, so the frameworks rather. So we're going to go through each of them. Okay, so now we've jumped to VS Code. And so here we have our terminal and then both the uh, Catch framework as well as the Google testing framework. So the Catch framework's on the left, and then Google test, appropriately named C tests and G tests, respectively. And so we see that the similarities across each allows us to think about tests and be able to port to one framework or another fairly easily. And there are scripts out there in the world that convert one from one to the other because some people are working in one test framework and not uh, always the same as the rest of the world. So converting your test cases from one to the other is a simple process. Generally, you can write a script for it, or you can do it manually. As we see here, when we're doing some basic implementations, right, we won't get super far into the nitty gritty of Google Test Framework. We're just going to use the basics of it, similar to Catch. And so we have that basic test case 0 set up again. We see here the only difference is how the name happens and how the actual test case call. So we see test versus test underscore case. And if we see down below, we have RandomBag1, which is constructor. So we'll rename that constructor. And then we have the add just below that. And so we follow that same strategy of having a description of the test as well as what does it require if it's requires something to be done prior to that test passing. So a different function that isn't in the name, right? We're required to implement size even though we're trying to test the constructor. And so simple port to Catch versus Google again. And then we have this first time we see in assert or that we want to pass to make that test pass. And so we have require in the Catch framework. Require in the Catch framework here, and we have a require meaning that we want this to be true in order to pass this test case. And so we set up a Boolean statement in there. In Google, on the other hand, there's several different types of expect statements, and the one that ports to require is expect equals. And so expect equals does not take a Boolean, right? But it takes two variables and compares them and says, I expect this to be equals to pass this test case. So we see that here, right? We have that Boolean comparison to size and the comparison to size through the framework. So that is the basic constructor. So if we scroll down a little bit here, we can see now we have test case 2 just for add. Again, we see the code is almost entirely the same, with the left just having a different function name, that test underscore case versus test, and then we're using require and expect equals for the Catch versus the Google test framework. But we're testing in the same way, right? We're going through and adding 10 things in this case, right? 1 through 10, not inclusive, so 9 things actually. And then we're checking each time through the loop. So this doesn't just check at the end, it checks every time something gets added to the bag to see if the size was properly updated. So we can go through and force this to fail by saying I+1 to see what happens when we actually fail a test. So let's make our G-test, and then we will make run. And we see down here that we actually get several fails. So let me put that at the top. We get our printouts. They all look the same because it's doing it 10 times. So we're failing here. The size was 9. We expected 10, right? So these are not equal. We're comparing these two things, r.size and I+1. They're not equal. That leads to a failure. And so we have our printout that RandomBag add failed. And then the other tests are still running. So we say, okay, we ran 4 tests, and then we, in one test suite, so one setup that we set up in one file, 3 of them passed, 1 of them failed. So that's what we'd see in our printout. And we'd see that, we can see kind of all of that getting printed out. We see at the top still we have that run and okay for the tests that we passed. So that is our setup, right? And we can see, I can show you the makefile here just really quick. Cat it out to the screen. And again, we have a makefile. All it does is compile the executable with specific needs, right? The Google test needs or the catch framework needs based on which you're trying to compile, make G-test or make C-test, right? You won't need both of those when you actually use your makefile because you will be using one framework. You won't have both of them in your setup. You don't need to have both of those, okay? So let's write a test. So let's go through and write a test here. And we have is empty. And there's a test that's missing here, the remove test. And so the remove test, let's clear out this terminal. The remove test really has us think about how to test remove from the random bag. So our random bag data structure removes a random item. So we can't put something in and then, or put 10 things in and then take it out, because that thing that comes out isn't guaranteed to be what we put in, right? We have 10 possible things. So you can test it by adding one thing and then removing it. That's guaranteed, right? We could also test it by adding several things of known values and then pulling them all out and then removing those known values. And so we're going to set up a little bit more complicated test to do that exactly. So we see our pop-up for VS Code. For test, we have test suite name and then test name. So this is our random bag test suite, and we're going to test remove random. Okay, and we're going to go about implementing this. We just want a random bag, and we need a counter for our test case, for this specific test case, because we're going to add a bunch of things. We need to know how many things we added, how many things we pulled out, make sure that the counters are the same, things like that. So a little bit more advanced than just putting one thing in and then pulling that one thing out and seeing if that would work. That's a basic remove random test. It's a good starter test, actually, but we're going to do something a little bit more complicated just to show what we want to do. So we're going to add a bunch of values to the bag. So let's make a loop. I equals 1, I is less than 10. I'm going to go less than or equal to 10. So we have 10 things going to the bag. Oops, plus I. And then we're going to limit the values because we need to know this is the set we want to put in. We could create a set. We could do things like that. We could get complicated, make a vector of answers. That's what we're putting in. We expect each of these to come back out, things like that. We're just gonna, we could do any of those things. So we're gonna limit the values to certain values. And we're gonna do that using the mod. So here we're just gonna limit to 3 different values. And that's not how I spell counter. So upon insertion, we're going to increment the counter. And then I forgot to put 1 and 2 after these. Okay, so we have each of those. And so we have each of those set up. So now what we've done is we've gone through the loop and we've gone through and created a random bag, counters, inserted into that random bag 10 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, modded by 3, which means we're gonna get 0, 1, or 2 as our values. And so now we can go through and remove all of the things. So this is just going to insert a bunch and then remove the things one at a time. And so we're going to check this. So remove items from the bag, and then we're going to remove them all. So while not is empty, so I pre-wrote that comment because I know in my test I will remove everything from the bag and I have to add things to the bag. So both of these have to be true. Is empty has to be working. We could just check size of 0, and that would make size our requirement instead of is empty. And we are simply going to get that value back. We also want to store the current size. So our cur size of random. So this is going to be kind of a catch-all. So we need size also. So we can remove one dependency by simply using size twice. So let's do that. So let's do that and say r.size is not equal to 0. So oops, I forgot my parentheses. So now we've removed the requirement of having is empty correctly done before. So we know that size was required for the constructor, right? The size was required all the way up here. Size is pretty much required for all of these. So now we're going to just require it for this one as well. So it needs add as well as size. And so now we have our check. And so we have our size. We removed random. So now we want to make sure. So expect, oops, that's a capital, equals, and we want r.size to equal cur size minus 1. So we removed something. Did I spell that wrong? No. Okay. So I must have spelled that wrong. So we have that as our I think I have a missing something or other. We'll get to that. And so now we have our expect statement. Oh, that's not what we want. Expect equals requires two things separated by a comma. So we have each of those now that we're going to go through. Move that up a little. And we're going to make sure the size was decremented by 1 and only 1 each time through. We also want to check to see if our value, so we can get rid of, we have our checker value to check if x is one of the potential values. So we inserted either 0, 1, or 3. So we can go through and check for each of those. Is it 0, or is it 1, or is it 2? Sorry, I think I said 3 earlier, definitely meant 2. So there's 3 different values, 0, 1, or 2. And we can then expect equals there, and our checker should be true. Right? We can put comments. So the size is decreased by 1, and make sure that the value extracted from the bag is one of the potential values we inserted. Now, since it's random, if we insert a bunch of things, we don't know which 0, which 1, which 2 will be getting back out. But we know that we would only get 0, 1, and 2. So if we get a 3, then this is going to fail. Right? So we should expect 0, 1, or 2 here. And now, lastly, we're going to increment our counter because we passed each of these tests. So we must have successfully removed something from the bag. Now, the final test, we're going to validate number of things removed. going into the bag and coming out of the bag are the same. So just a quick expect equals of counter 1 and counter 2. So now we've checked 4 things, right? So simple test case that we've written, inserting 10 things in that are all 0, 1, and 2, or 2, and then removing them all one by one, and removing them all and checking that the size is being decreased, that it is a valid value, one of the 3 possible values that we got, and that everything that was inserted, right, the same amount of stuff that went in came out, right? So that means that we didn't accidentally extract 2 things from the bag. So we have that here. Again, let's make sure it compiles. That's always important, right? So we edited the g-test, so we're going to compile that there. We see that it compiled, so then we can do make run. And we still failed because I forgot to update this back. So we got to fix that. So again, we changed our, wrong area. Clear, make it, and run it. So we see we've passed all of our tests. So this should not be the norm for testing, right? I've already written the random bag. We've gone through and test that. So we can go and make it incorrect shortly. We'll go through and fail a test on purpose to see what that is without just failing on our end, right? We've already seen what it means to fail here when we just change one of these to be incorrect. And so let's change the code to fail the test. Okay, so we have here on the left the random bag file. Let me make these a little bit, make the terminal a little bit smaller. There we go. And there we go. And so we've seen kind of our test. We went through all that. This is the implementation of the random bag now over here on the left. So we just wrote a remove random. So what if we actually removed 2 things, right? So this erases the rth element in the greater than 0. Do it again. So if we have, we're just going to pop the back. We're just going to do that. We're just going to elements.pop. All right, so now what it does is not only erases the element, but pops back the element, right? And so we expected to only get rid of 1 thing at a time, and now we're getting rid of 2 things at a time. And so we should fail one of these tests now. So let's compile and see if we actually fail these tests. So we're going to make g-test because it's quicker to compile. We actually didn't need to make it. Yes, we did, because we include the random. Sorry, we changed some code. So clearly, we were going to. Good. So now we've failed again. Let me put this at the top here. So we failed 1 test listed below, the remove random, which is what we expected because that's the edit we made. We made the edit in the remove random. Now we failed that. It's going to fail and print out all of those failures. You can look into Google Test Framework and change up what this is, and that expect equals we can change to a different function, a different framework call to allow us to stop, right? To stop the test harness or the test suite immediately so that it doesn't print everything. It would just print the first failure. And so we see here that we expected our size to only be decremented once. and it actually is decremented twice, right? We check the size and it's 8, and now we see that we expected 9, right? Curve size -1. So this is where having good variable names can help, right? Checking the actual size versus the expected size, maybe that would be helpful there. We can also see the other test case that fails down here. The last one, counter 1 versus counter 2, fails because counter 1 put 10 things in, so it had 10 adds, and counter 2 says only 5 values were acquired when we called remove random. We only removed, or we only counted 5 things before we emptied the whole bag. Now, as we know, because we updated the code, 2 things were removed at a time, so there were still 10 things removed, but from the public facing perspective, only 5 things got removed from the bag because you only called remove 5 times and you acquired 5 values. Right? And so that's how we would check. So that's one of the reasons you can write test cases before you know you're done with the function, right? So you implemented and you're writing a bunch of test cases. Now the test cases kind of put you in perspective where to check, right? What to check next as far as code so that you know that you've tested sufficiently, right? So we could easily pass a remove random test if we did the implementation that we talked about, the simple one add, one remove. Maybe that just works. Maybe that one works because it's the first thing, right? And you have pop back in there instead of erasing the index. And so now that passes the one test case, but when you go to a more advanced remove random test case, it's going to fail. And that should lead you to understand more where your implementations are failing. And so understanding that you can develop tests even before you're done with the function, right? You know what the function should do, right? And so you can test it even if you don't have the functionality of the entire function implemented. So it's not about always just, hey, let me write the function, write the implementation, then let me write a bunch of test cases to prove that this is correct. You could do them in parallel, doing some tests writing and then some function writing, or do some test writing first and then function writing, or doing additional function writing after you write several tests and note that you are missing some edge cases, right? So all of those things can happen in parallel. And often when you're thinking of how to implement your function, right, if you don't have a solution to check against, you're coming up with test cases and edge cases and things like that to say, okay, if this happens, I need to handle it, right? And so that's a test case, right? How do you write that test case and go about doing that? So that's the random bag. Let's fix it so it's not broken anymore. Let me show you, actually, let's break it again. And I'll show you the test framework for C-test. So we're gonna make C-test. All this does is make the catch framework instead of the Google framework. And so it takes a bit longer to compile because it's including everything under the sun. And then once it's done, hopefully it finishes. There we go. We can see that we're going to push that upwards. And we have our remove random is what is being tested. Line 75 of the testing file is where it's failing, and we're looking to have these two things match. And then when it was expanded, we found 9 and 5. Right? And so if we look at the C-test framework, again, I pre-wrote that, but it doesn't have all these other expects. So we only have the require that the values are the same, and then the counters are the same. So we didn't get the printout every time because we have curve size -1 here. We don't actually do that over here. And so that's the difference between these two tests, is one will just check the counter at the end, and this one checks the size every time. And so we see that expansion 9 times versus 5. Again, this isn't exactly the same. Let's update that just so that the code is the same. And so the insertion code, at least. So 9 insertions, 1 through 10 not inclusive before there. And so that's the catch framework. That's what it looks like when it does not pass. So we see there that we're getting 4 passed, right? So test cases, 5, 4 of them passed, 1 failed. Assertions, 18, 17 passed, 1 failed. And so we see that one assertion that was a failure right here. All right, that's a wrap. That was testing with frameworks. So went through Google test, went through catch, redid some of the basic testing framework to give a clarity on these frameworks. Then you're off to do it on your own. Choose your own adventure, so to speak. Catch or Google. It's your choice. Have a great day.